Dude, that's crazy. Welcome, Intro to College Algebra students. Today we're going to look at simplifying and evaluating algebraic expressions. Jump in with an example to see what we remember. Let's say I've got something like this. Maybe I've just found the area of a rectangle, or that's what I'm supposed to find, and one of the lengths is given to us with an expression with an x and a y in it, and we just have to simplify this. So we're going to use something called the distributive property. Distributive property, and remember what I said about taking notes, especially in a math class. If there's something you already know, you don't necessarily have to write it down, but just make sure that you actually know it. For instance, distributive property. Most kids remember to take 5 times x, which gives you 5x. But a lot of them don't remember to take 5 times 3y, which gives you, what's it give you? So think to yourself, you have 3y, you got it 5 times. So if you've got y, there's 3y, little plus signs between them. And then you got 4 more of those, then you got 15 y's. 5 times 3 is 15, so 15y. So that is something that quite often people forget to do, is that second multiplication. Okay, so that's distributive property. Now there's something else called combining like terms, which if I've got something like this, and I'm just going to make something up here. Okay, so let's say I've got an expression like this. Combining like terms means that I'm going to take anything with the same variable and the same exponent, and I can add or subtract them from each other. So combining like terms. So you may want to write down same variable with same exponent. For example, 3x. So 3x and negative 4x are like terms, because they're both an x to the 1 power. So these are both x to the 1 power. X to the 1 power. X squared is not a like term because it's got the second power, different exponent, so same variable, but they don't have the same exponent. And then the 3y is not even the same variable. It does have the same exponent, but it's got to have both. So we can combine these. These are like terms. So think to yourself, I've got $3. I'm trying to pay $4 because I'm taking it away. So I still owe $1. And owing $1 is a negative 1. So negative 1x plus 2x squared plus 3y. So that is technically simplified now. But generally, you're going to see these written with the higher power first and in alphabetical order. So you're going to see 2x squared written first, then just minus x. You don't need to have the 1 there, but you can if you want to. And then the 3y at the end. So you may want to write down often written, something like this does not have to be exactly this. You need to write what makes sense to you. Often written alphabetically with bigger exponents first. Biggest exponents first. Go ahead and see if you can answer the following questions just as practice. Let's try another example together. Let's say we've got something like this. I seem to like 3x. Check that out. I use 3x a lot. Okay, so we got something like this. We're going to have to do several things here. I recommend doing your distributive property first, as long as there's nothing in here that you can simplify. And I can't simplify y minus x. They don't go together. They are not like terms. So I can't put them together. So I'm going to go ahead and distribute. You may even want to write a note to yourself to try to distribute first, after you've simplified in the parentheses. So I've still got a 3x here plus, and then 2 times y, then 2 times negative x, and then plus x squared. Okay, so I distributed. Again, you may want to write a note to yourself, distribute. Next thing we're going to do is try to combine like terms. So I am looking for the same variable with the same exponent. So same variable, okay, so here's 3x. 2y is not the same variable, 2x is. And then x squared is the same variable but not the same exponent. So those are not like terms. So I can combine these. So I have 3x minus 2x, that's just 1x. And then plus 2y plus x squared. Now this is technically correct. This is technically correct, but generally you will see things written, and it's just convention. You'll see things written alphabetically, biggest exponent first, so usually you'll see something like x squared first, and then the single x, and then the 2y. But these are equivalent, we just kind of rearrange things. Other one. So I've got one with a's and b's this time, so it doesn't have to be always x and y, but the same rules still apply. We're going to look for like terms, and this time might have potentially some other ones. So I've got nothing to distribute, so I don't have any parentheses, but I do have some like terms. 4a and negative 3a are like terms, and then negative 5b and negative 8b are like terms. And think to yourself, why did I not highlight 2ab? Should I have? Is 2ab like terms with one of these? Think about that for a second. And the reason they're not is because I've got both variables here. In order to be like terms with 2ab, I would need to have another a times b together. So that's kind of like why x squared and x are not like terms. They have one of the same variables, but this has two x's, it's just one x being multiplied. This has a and b. These are just singulars, a or b. So you can't combine the 2ab with anything else, unfortunately. All right, so let's go 4a minus 3a. Well, if I have 4 of something and I take away 3 of them, I just got one left. So that's just going to be 1a. Then I have negative 5b, negative 8b. So think about, those are both negative. I owe $5 to Mr. Smith, and I owe $8 to Mrs. Walker. So altogether, I owe $13. So this is a negative 13b. And then just plus 2ab all by itself. And then just remember, when your 1 is a coefficient, you really don't need to write it, so you may just see a minus 13b plus 2ab. Something like that. All right, let's try one more of these. Oh, got some distributive property. Okay, so I've got to distribute. First, can I combine x and 4? And the answer is no, they are not like terms, so I cannot combine them. But I can distribute. 2 times x is 2x. 2 times 4 is 8. Then 3 times x is 3x. 3 times negative 5 is negative 15. and then just minus 2y. It's a great time to put another reminder for yourself to not forget that second multiplication. Or if there's even more things in the parentheses, don't forget the third multiplication or the fourth multiplication, and so on. Okay, so what are my like terms? See if you can figure out the like terms before I highlight them. So 2x, I'm looking for same variable, same exponent, 3x. Okay. And 8 and 15 are technically like terms, so they're going to go together. Any like terms with 2y? Think about it. In the meantime, we got 2x plus 3x, which is 5x. Then I've got 8. Let me go ahead and highlight them. 8 and negative 15. So I have a positive and a negative. So think to yourself, I got $8. I'm trying to pay out $15. So how much would I still owe? Well, I still owe $7 after that. So this is going to be a negative 7. And then just minus 2y, because it doesn't have any like terms. So sad, all by itself. And then you're usually going to see what the variables written first. So 5x minus 2y minus 7. These are the same. They're just rearranged. So just remember that you'll conventionally see it more like this rather than like this. Okay, now evaluating. So evaluating is a fancy word that means plug in numbers. You may want to write that down for yourself if you don't already know that. So evaluating just is a fancy way to say plug in the numbers. Plug in numbers. So let's actually go ahead and take this expression that we just simplified. And you're going to see something such as evaluate 5x minus 2y minus 7 when x equals 2 and y equals negative 1. Why not? So all you do, everywhere you see an x, you're going to put a 2, and everywhere you see a y, you're going to put a negative 1. So I'm going to start off with 5, and then instead of writing x, I'm going to write 2, then a minus 2. Instead of y, I'm going to write negative 1, and then finally minus 7. So 5 times 2 minus 2 times negative 1 minus 7. Then you got to remember your order of operations. Okay, so start inside the parentheses. Can I do anything to 2 or to negative 1? Not really. They're just single numbers. There's nothing I can do to the 2. There's nothing to evaluate there. Next, you would want to take care of any exponents, which I don't have any. All right, all I've really got here going on is multiplication and subtraction. So let's take care of that. Multiply and divide, you're going to start at the left and just go towards the right. So first I do 5 times 2, which is 10. Then I'm going to do 2 times negative 1. I have a minus, and then 2 times negative 1. You can also think of this as negative 2 times negative 1 if you prefer. So negative 2 times negative 1, and then that would be a plus, is just a positive 2. And then minus 7. If you had thought of this the other way as a 2 times negative 1, you would have gotten a minus negative 2, which still comes out to a plus. So it works either way. Okay, then we want to add or subtract. So 10 plus 2 is 12 minus 7. And finally 12 minus 7 is 5. So when we evaluate this for x equals 2 and y equals negative 1, we get 5. Doobie-doobie-doo, does this record sound? I don't know.